Chapter 19, Review for Test. Now, the multiple choice part of the test, the first 10 questions, these are all conceptual questions. You're going to be using your right-hand rules to do these. So number 1 says, which diagram below best represents a magnetic field? So first of all, we want a magnetic field, not an electric field. So first of all, because this has positive and negative, we're just immediately going to cross off those two choices. So a magnetic field, we're looking at the field that exists between north and south poles of a magnet. So what we need to know is we need to know the one rule, and the one rule is that it goes from north to south. So from north to south would be choice D, and we see the arrows pointing in that direction. Number 2, it says in the diagram above, what is the direction of the magnetic field, should be below, at point P. Now what happens is, first of all, we're going to see, and we see that we have two poles that are the same. So we know that there's going to be repulsion. The next thing we know is that from north, the lines go out. So the lines are going to be going like this. So the question says, like this. So when it says, what is the direction of the magnetic field at point B, the direction, because the lines are going like this, they're going to be towards B. Number 3, which diagram best represents the magnetic field between two magnetic north poles? So these are going into north, so they don't go into north. This shows going from north to north. We know that these are going to repel one another, and their lines are going to be going out, just like the other one, so the answer is obviously A. Now you notice that these questions, there's no calculations, that these questions require about 10 seconds or less to do. Number 4, which diagram correctly shows a magnetic field configuration? So remember, magnetic fields go from north to south. So this one's going from south to north. North and south, they attract one another. This shows repulsion. This shows going from north to south, and the lines are going that way. And then this is going, I don't know what this is doing. So the answer is C. So again, unlike poles attract, so there's a force of attraction, and it goes out of north and into south. Okay, number 5, it says electrons are flowing in a conductor as shown in the diagram. What is the direction of the magnetic field at point P, which is right here? Now, there's more than one way you can do this, okay? This is a conductor, like a wire. Now, the electrons are going this way. The definition for conventional current is conventional current, I, goes in the direction opposite the flow of electrons. So there's more than one way to do this. If you want to, now remember, the right-hand rule is the thumb points in the direction of the conventional current. So if you put your hand, remember, these have to be perpendicular. I saw somebody going like this. You're always going to keep your hand flat like this until you get to the point where you're on the conductor, but the fingers are perpendicular to your thumb. Now this, I think, is awkward, because if I turn my hand like this and put I down and I go like this, you see my fingers, let's say this is the wire, if I put it, I have to stand up, then if I go like this, my fingers, you see, are coming out of the page. What I think is easier to do, and I taught you this before, if it's electrons, instead of using your right hand, what should you do? Use your left hand. So because it's electrons, if you put your left hand and you go like this, you get the same thing. Your fingers are pointing out. Remember, so these are coming out. Remember, the dot represents coming out. The X means going in. Now, you don't have to draw that. So again, if you used your left hand going around the wire, this is the direction of the electrons, and then the fingertip shows it's coming out of the page. So the answer is D. I find it easier whenever we have electrons, instead of trying to always use my right hand and do the opposite, I think it's easier just to do the left hand. And you guys saw that when we were doing the other homeworks, right? I don't know why some people insist to do the right hand, just use the left. All right, number 6. It says electrons flow in a loop of wire as shown. So this shows the electron flow. So it says, what is the direction of the magnetic field at point A? Again, I would just use my left hand. So pretend you're wrapping your fingers around the wire like this, because the electron flow is going this way. Your hand would be wrapping around, and at point A, they would be coming out of the page. The diagram below shows a coil of wire connected to a battery. The north pole of the magnet is towards the positive end, so that's going to be C. We could use our rule for that, but we already see the flow of the electrons. Number 8, when an electron moving in a magnetic field experiences a magnetic force, the angle between the force and the electrons and the lines of flux is always. This is just the definition of the right-hand rule. So these are always what? They're perpendicular to each other, and perpendicular is what? 90 degrees. Remember, the electron's moving, that's your thumb. The magnetic field is your fingers, and they're always perpendicular, so that's why it's 90 degrees. Number 9, when electrons flow from point A to point B in the wire shown in the diagram to the right, there will be a force produced on the wire. So now, remember, when we have our hand, there's more than one way to do it. It says electrons are flowing from A to B. So the electrons are flowing this way, but my conventional current is going this way. So if you're going to use conventional current I, you would use your right hand. If you're going to use your electrons going down, use your left hand. So I'm just going to use my left hand. Oh no, it says electrons flow from A to B. So first of all, what we do here is you need to draw what's happening, the magnetic field. So we know it goes from north to south. So I'm going to draw this like that. Now, I'm going to use my thumb for the electron flow. My fingers is the magnetic field. So watch. This is going down in the direction of the magnetic field. My fingers are going from north to south this way. So the palm of my hand, is it facing into the page or out of the page? It's into the page, and that's it. And then the last one says, which diagram best represents the magnetic flux lines around a bar magnet? So this shows going into north and out of south, so that's wrong. This is also wrong. This shows going from north to south, and oh, that's not right, because this shows them crisscrossing, which they don't do that. So the answer is D, because the lines don't crisscross like that. What I did was first I looked at the arrows and I didn't notice this little part here, so that just tells you you have to be really careful and look carefully at that to see little things like that, because I try to trick you. All right, the next 5 multiple choice questions on the test before the reading paragraph, those are from the 2 equations from the chapter, but they're really simple ones. They're ones where you write down the equation and you plug in the number, so those shouldn't take that long. So even though there's 5 of those and they're multiple choice, it's not like you have to show all your work. Then the FRQs are going to be 1 for each equation, and that's it. There's only 2 equations for the test.